Hi everyone, welcome back. In today's video, we are going to learn more about covalent bonding. As we have discussed in our previous video that covalent bonding is the sharing of electrons between atoms. Sharing of electrons between atoms. And the condition for formation of covalent bond is that always it is always between two non-metal atoms. So for example, we discussed about ammonia. So ammonia, nitrogen is a non-metal, hydrogen is also a non-metal. So how do we show the covalent bonding in nitrogen? So what we do is first we write electronic configuration of each element. So nitrogen, atomic number of nitrogen is 7. So this is the electronic configuration of nitrogen. In hydrogen, it is 1s1. And as I said before, why there is need to form bond is that all elements tries to attain a stable gas configuration or the nearest noble gas configuration to attain stability. So in case of nitrogen, there are 5 valence electrons, and we have already discussed for bonding only valence electrons are involved. So there are 5 valence electrons in nitrogen, and there are 3 hydrogens here. So what we do is nitrogen is a central atom and hydrogen is surrounding the nitrogen, 3 hydrogens. So because hydrogen needs one electron to attain duplet. So this is the exception. Hydrogen needs only one electron to attain duplet, not octet. So we write hydrogen Lewis, we are writing Lewis dot structure or electron dot structure for ammonia. So one hydrogen has one electron, this hydrogen has one valence electron, this hydrogen has one. So because hydrogen needs one electron to share with nitrogen, so we will write nitrogen electrons like this, and then the remaining two will be written like this. So this hydrogen has completed its duplet by sharing one electron with nitrogen. Similarly, the other hydrogen and the third hydrogen. So hydrogen has attained the stable configuration. Now what about nitrogen? So nitrogen will also share 3 electrons with 3 hydrogens. So this is the way to show the sharing of electrons. So we can count 1, 2, 3, 4, 5, 6, 7, 8. So there are 3 covalent bonds. So there is a covalent bond between each hydrogen, and these 2 electrons which are not involved in bond formation with hydrogen is known as lone pair. So the electrons which are not participating in bond formation is known as lone pair electrons. So this is how we show covalent bonding in ammonia. Then there are some exceptional cases which we need to see, even though they are not obeying the octet rule, still they are stable compounds. So that's why we are saying these are exceptional. So for example, boron trifluoride, BF3. So boron is a non-metal where fluorine is also a non-metal. So atomic number of boron is 5 and fluorine is 9. So if we write its electronic configuration, so it is 1s2, 2s2, 2p1. And for fluorine, 1s2, 2s2, 2p4, 2p5. So in boron, there are 3 valence electrons which are participating in bond formation. Whereas for fluorine, there are 7 electrons, valence electrons, which are participating in bond formation. So if I show boron, So fluorine needs one electron to complete its octet or to attain stable gas configuration. So we write this way, fluorine, and the other 6 electrons will be written like this. So only the shared electron will be between two atoms. The other electrons we can write this way. And boron has 3 electrons in its valence shell. So this is how we write. So this fluorine will complete its octet. This fluorine will complete its octet by sharing 1 electron with boron. Similarly, this one. But what about boron? Boron is sharing 3 electrons with fluorine. So total electrons present are 1, 2, 3, 4, 5, 6. So even though it has 6 electrons, still it is stable. So this is an exceptional case. Then we have another exceptional case like PCl5. So phosphorus and chlorine. Phosphorus, atomic number of phosphorus is 15 and chlorine is 17. So we write its electronic configuration. So this is the electronic configuration of phosphorus, and for chlorine 1s2, 2s2, 2p6, 3s2, 3p5. So as phosphorus has 5 electrons in its valence shell, it needs only 3 electrons to complete its octet. Whereas for chlorine, it has 7 electrons in its valence shell, so it needs only 1 electron. So how will we show the sharing of electrons between phosphorus and chlorine? And that, as I told you already, these type of structures are called dot structures. So phosphorus is the central element and chlorine is surrounding the phosphorus, 5 chlorine atoms. So we will write each, because of chlorine needs 1 electron to complete its octet. So we write this way, and the other electrons will be written this way. So this phosphorus has 5 electrons. So 1, 2, 3, 4, and 5. So this will share here. This will share this way. This will share this way. This will, and this will share this way. So all chlorine atoms have attained stable configuration by having 8 electrons in their valence shell by sharing 1 electron each with phosphorus. What about phosphorus? So if you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 electrons. Instead of 8 electrons, it is having 10 electrons. Again, it is an exceptional case. So these are some of the examples of exceptional cases. Now we will move to the types of covalent bond. So there are 3 types: single bond, single covalent bond, double covalent bond, and triple covalent bond. So what is single bond? Single covalent bond is the bond forms when atom shares one pair of electrons. Single covalent bond forms when atoms share one pair of electrons. Double bond is when the atoms share atoms share two pair of electrons. And triple bond is when atoms share three pair of electrons. So we will discuss single covalent bond. I'll explain it with help of an example. Simple example is, for example, if I take polynuclear molecule which contains, or polyatomic molecule which contains more than two elements. So in this case, oxygen is the central atom and hydrogen is surrounding the oxygen atom. So each hydrogen has one valence electron, whereas oxygen has 6 valence electrons if you see its electronic configuration. And for hydrogen, it is 1s1. So 1, 2, this way, and this way. So total valence electrons in oxygen 6, and for hydrogen 1. So hydrogen will share one electron with hydrogen, this oxygen will share with this, and the oxygen will have this. So there is one electron pair between this hydrogen, one electron pair between this hydrogen and oxygen. So this bond is called single covalent bond because it has only one electron pair present. And these two which are not participating in bond formation are lone pairs. So there are two lone pairs on oxygen. Take one simplest example if I take hydrogen. So hydrogen, hydrogen, this one, this one. So there is sharing of electrons. So this is one electron pair shared between two hydrogen atoms. So it is also an example of single covalent bond. Thank you so much for today.